Welcome to Cambia Grove. I'm Julie Anderson. I am the Assistant Director of Strategic Initiatives here at Cambia Grove. And before handing the mic back over to Paul, I would like to just say a few words about Cambia Grove. But actually, before I do that, I will pause the music since it is louder than I thought it was. Oopsies. There we go. That's better. So Cambia Grove is a healthcare innovation hub. We are focused on bridging the gap between entrepreneurs and the traditional healthcare sectors to drive system-wide transformation. We offer free and open co-working space Monday through Friday, 9 to 5. So if you're working towards healthcare transformation, feel free to come back through and use our space. We also have some more private rooms in the back if you would like to reserve them for meetings or for calls, etc. And we also offer a slew of educational programming really serving to demystify the traditional healthcare system for the entrepreneurial community. So I would like to invite you to find us online, sign up for our newsletter, and stay abreast of our upcoming events and programs. And feel free to find me if you have any questions during or after the event, and then come by anytime, Monday through Friday, 9 to 5. So with that, Paul Meehan.
Thank you. As a former entrepreneur in the field, Cambia Grove is an awesome place for startups because you can get all of this for free. All you have to do is show empty pockets. Okay, so my name is Paul Meehan, and I'm the chair of the MIT Enterprise Forum Northwest. And our program tonight is Making a Difference, the Role of Technology in Fighting, Treating, and Living with Cancer. The MIT Enterprise Forum is an organization of dedicated professionals with 28 chapters located around the globe, affiliated with the Massachusetts Institute of Technology through the MIT Technology Review. So our members do not have to be MIT alums, unlike everything else that's MIT affiliated. We allow people who are not MIT alums, such as myself, to join in the fray. And so we also are reaching out to entrepreneurs who are not MIT alums to help get your products developed. And you are cordially invited to our program on art and technology in the 21st century that'll be in January, the third Wednesday. And that should be a lot of fun. We're a volunteer-run organization of people who seek to be inspired and educated through technology leadership. This program would not have been possible without the dedication of the following volunteers: Ben Wheatgraf, Željko Želic, John Locke, Alexander Theoharis, Toussaint Myrix, Mark Anderson, Vicki Owens, David Anderson, and Amelia Polaveva. Hey, 1 for 2. I used to teach at UCLA, so occasionally I get names right. Our programs are made possible by Freelock Computing, the MIT Club of Puget Sound, the Harvard Club of Seattle. We do talk to the Harvard Club, so we're not, we'll walk across the street occasionally. The Keiretsu Forum and Puget Sound Video, thank you very much. Our moderator tonight is Amelia Polaveva. She's a consultant for the intersection of technology, business, and design to help companies identify areas where innovation can make a difference. Previously, she led the marketing and business development strategy at Artifact and led global marketing campaigns for Fortune 500 clients and breakthrough emerging technology startups. So, I'm turning it over to Emily.
Okay, thank you for coming. We have a great panel here, and before I introduce everybody, I just wanted to give you a little bit of background on why we chose cancer as the topic of discussion. Every time MIT Northwest Enterprise Forum meets, we have a broad technology that we want to discuss with the community, and this month's topic was healthcare. And when we started putting the panel together, we wanted to zero in on something that would have impact on everybody. And I think we can pretty much safely say that there isn't anyone in this room that hasn't been impacted by cancer, whether directly or indirectly. Just a few statistics to give us all a sense of how large this problem is and how impactful it is. According to the World Health Organization, 1 in 6 deaths worldwide is by cancer. In 2018, an estimated 1.7 million people in the US will be diagnosed with cancer. And of those, 600,000 would die. And just earlier this week, the Center for Disease Control predicted that by 2020, the leading cause of death in the US as a result of the aging population would be cancer. Cancer would surpass heart disease. So with that in mind, technology is making huge progress in treating, understanding, and making improvements in living with cancer. And we live in a place where the intersection of data, the intersection of medical research, and a lot of entrepreneurial spirit is coming together to create a hub for cancer advancements in cancer treatment and cancer science. So I'm really happy to have with us tonight four really prominent researchers, technologists, and practitioners in the field. And I'm going to use my notes as I describe their backgrounds just because they have a lot of credentials that I would screw up trying to describe. But first is Dr. Abby Rosenberg. She is a professor of pediatrics at the University of Washington with joint appointments in the divisions of bioethics and palliative care and hematology and oncology. She's also the director of palliative care and resilience research at the Seattle Children's Research Institute. And her team, she and her team work to create scalable interventions to promote patient and family resilience. She received her MD from Stanford and did her pediatrics residency and fellowship at Seattle Children's and University of Washington. Then we have Ankur Teradesai. Ankur is the co-founder and chief technology officer of a local data science company called Kensai. Their mission is data science versus death. He also holds a professorship in computer science and systems at the University of Washington and has held various positions at Microsoft Research, IBM's TJ Watson Labs, and a variety of technology startups. He's published over 75 papers on machine learning and its impact in healthcare and other social areas. And he's also the executive director of the Center for Data Science at the University of Washington. Then we have Sarah Gosline. Sarah is a PhD and a senior research scientist at Sage Bionetworks, a nonprofit organization dedicated to creating platforms for scientists to collaborate and for patients to become engaged through their data in developing new treatments for complex diseases. Sarah is leading the diverse research communities to increase collaboration via data curation and establishing standards of data sharing. She works with bench scientists to enable computational integration of diverse data sets so that scientists can discover cures for diseases faster. Specifically, she works to bring computational system biology approaches to study neurofibromatosis, a cancer-causing syndrome that affects 1 in 3,000 patients, and there is no discovered treatment yet. And to my left is Dan Webster. Dan is the principal scientist of digital health for Sage Bionetworks, as I said, a nonprofit research organization that's dedicated to open science. He leads the company's digital health efforts, including conducting app-based remote research studies to detect and manage disease. He's also part of the collaboration with the Precision Medicine Initiative's All of Us longitudinal study. Dan is also known as the creator and designer, creator, and developer of the original iOS Mole Mapper app, which is part of Apple's Research Kit, and is designed to take real-time longitudinal photos of precancer lesions so that patients and doctors can communicate better and discover cancer earlier. He studied genetics at the University of Wisconsin-Madison and cancer biology at Stanford, and was postdoctoral research fellow at the National Cancer Institute. So with that, I want to invite you to tell us in normal people's terms what a day in the life of a cancer researcher, technologist, data scientist look like, and how does the work you do daily impacts cancer, knowledge about cancer, cancer science, patient outcomes. And as much as possible, tell us a scenario or a product or an initiative that is making progress. I'm going to name names. Abby, let's start with you.
Okay. Hi, everyone. Good evening. Thanks for being here. I'm Abby. I'm a pediatric oncologist, as you just heard, and a palliative care physician at Seattle Children's up the road. And a typical day in my life is 3/4 of the time spent right across the street at our research institute, really thinking critically about how we can improve the well-being and the stressors and the overall experience of children and families who are facing pediatric cancer. And Amelia didn't ask me to do this, but I feel like part of the story that I want to share with you all is really how I got to doing what I'm doing. And it started for me a very long time ago, sitting across from a family of a baby who was exactly the same age as my son, and having to tell them that their baby had cancer. And I remember in that moment thinking that all of the biology and all of the things that I was going to say next were going to be insufficient to this monumental moment in this family's life. And I felt like what we do in oncology research tends to focus on that biology and less about the overall experience, and my vision was to try to fix that, in particular in the pediatric cancer world. And so over the course of the rest of my career, we have been focusing on how do you create scalable interventions, meaning something that I could deliver and Amelia could deliver and someone at MIT could deliver consistently so that we're improving these patient and family experiences. So what we have done here is create a program called PRISM, and that stands for Promoting Resilience and Stress Management. And essentially what it is a really brief, kind of holistic psychosocial intervention where we teach patients and families some basic things in addition to all the biology medical stuff that they will need in order to navigate their cancer experience. And we have tested that enough times to know that it actually really works. It helps teenagers feel better, it helps parents feel better, it helps people manage their illness better, it alleviates the risks of depression and anxiety and other mental health disorders over time. And so now the reason I'm here is where we have pivoted in that intervention to say, in delivering it to teens, this was really great, but we were meeting with them, and anyone who has teenagers or who has ever met a teenager knows that how they communicate now is through their phones and with texting. And so the teens that we worked with said, you know, we like talking to you, but we'd really like to text with you more. And we don't really want to have to meet with you in person. We'd rather speak this language that we speak, which is digital. And so we created an app which teaches this program now to kids and families, and we are learning how to implement it on a larger scale so that we can really put this thing into the hands of every single kid with cancer and every single parent whose kid has cancer. So that's what I do.
So it's amazing to beat that. It's going to be hard. So hi, my name is Ankur Tere Desai. I'm the Chief Technology Officer and co-founder of a company called Kensai in Seattle. We are actually a spin-off from the University of Washington, and my own journey with healthcare machine learning. So I've been doing machine learning and AI before it was cool, from the 90s, and around 2007 timeframe, after getting tenure at the University of Washington, something changed. And I started focusing more on domains which will have a societal impact. So I wanted my work in AI to be meaningful. And so as a small project, I started working collaboratively with Fred Hutch Cancer Research Center, with a team of oncologists and nutritionists, and with Alex Mamishev in the electrical engineering department at UW. And together we started building an app for oncology patients who are going through chemo at that time to record and study how nutrition and what they eat affects their oncology, their chemotherapy treatments. Because as we all know, nutrition is a very big part of cancer care. and weight management is quite important. That just opened up my eyes to the fascinating world of healthcare and machine learning. And since that day, I have not sort of looked back. Today, I have not only authored quite a few papers that have been impactful in this space, but I've had the immense fortune to be able to work with health systems across the world. So my day literally begins with talking to folks in Sweden, in Karolinska, UK in NHS at 7 o'clock in the morning, trying to work with them on solutions for diseases like COPD. We have an active project going on with the entire population of Scotland, where we are risk stratifying over 100,000 patients with COPD and sending them home with NIV devices. Then I get to Seattle, and I spend time with data scientists on the team, looking at machine learning models and how we can make them better in terms of explanations. So a big area that I'm focusing on in my research right now at Kensai is explainable machine learning, because nobody in the world of healthcare wants machine learning models that are not explainable, that are not interpretable, so that physicians like you can actually use them. So we are trying quite hard to focus our attention on that. I have in the audience one of my principal data scientists, Mohammed Ahmed, who's a longtime collaborator and a world-renowned expert in explainable ML. And then back into afternoon, I start working with folks in Kaiser, in US Army, and then shift my focus towards a wonderful country called Singapore, where Kensai is quite involved in risk stratifying the population of Singapore for prediabetes and diabetes risk. And then, I get some time at night to actually read up on papers and find a few hours of sleep. But what is fascinating for me is, while I travel the world and look at disease conditions and how AI and machine learning can help solve for better patient outcomes, Seattle is really the home where it all begins. And we have an amazing movement going on in Seattle focused on healthcare that is just unprecedented, with both the triad of the cloud, the compute that it provides, the availability of data, and amazing institutions such as Seattle Children's, UW Medicine, and many others that really bring it all together. So I'll talk more about some of these works as we go along, but just wanted to put that up.
So my name is Sarah Goslin. I'm a senior scientist at Sage Bionetworks. Unlike everyone else here, I have not designed an app. So I apologize for possibly boring you with my work. Thanks. But I did come to this field as a computer scientist, interested in really challenging problems. And I studied computer science in undergrad, and got my PhD in it. And I've slowly been migrating to the cancer field because this is where the really challenging problems have been and the really exciting movements have been. And there's a lot of efforts in cancer biology, cancer systems biology, where people are taking the data sets, the very basic science, your genes, your transcripts, your proteins, and trying to study the patterns in them, identifying which patterns will give rise to cancer and otherwise. And as I moved to Sage, that kind of co-occurred with Joe Biden's Moonshot Initiative. And Joe really kind of did this whole tour of the United States. And one of the really pressing issues that he noticed after Bo was diagnosed with cancer and then passed away was that scientists weren't communicating with one another. The treatment that Bo got at one institution, the virus that was used to transfect the cure to his brain, was a different virus that was not tolerated compared to another institution. And people weren't sharing ideas, and people weren't, they had different results, and one clinic would have one study, another clinic would have another, and no one would really be aware of what was happening. And this is actually a really big opening for technology, and something that Sage has really jumped into is actually just a platform and the data sharing platform that we use. And we have now a data sharing platform. We're acting as data coordinating center for many cancer-related grants, where different scientists will upload their results and will help basically make sure that everyone's communicating and sharing the data in a meaningful way, that it's queryable. So when you Google something and you put in, where's the nearest grocery store, it has curated all the grocery stores in your area, so it's really easy to find. But no one has done that. I know which gene responds to my kinase inhibitor. No one has annotated that yet, so we're working on that. And so really this kind of very unsexy problem of making data available is something that technology is really ripe to solve and something that we really focus on. And something that Ankur really drove home is that Seattle is amazing for this, not just for the reasons you said, but because of the people. The people are really eager to think outside the box and think about these problems in a different way. And we've seen with the rare disease field that I work in, neurofibromatosis, that if you get enough people in the same room, you can really cover an entire research field. It's a small disease field that I work in, so I'm able to talk to clinicians, I'm able to talk to scientists, get them to talk to one another, and make sure that the results that the scientists are generating in the lab are actually visible to the clinicians who are desperate for any kind of drug to treat the kids that that are giving rise to these symptoms. So it's a really different side of the science that I work in cancer, but it's something that is really being driven by the technology and good opportunity.
Hey everybody, I'm Dan, and my day is usually an interesting one that maps across a few different fields, but I think that what it really comes down to is thinking about how you can use technology, and most of all the technology that kind of lives in our phones and on the smartwatches that we have, to be thinking about your health outside of the times that you're directly working with your physician and all of the time between those periodic visits. And that really started from more of a personal experience for me, where I come from a cancer genomics background and was working on melanoma in the lab, doing genome engineering, and then spending all my time with very small liquids. And at the same time, having a wife who's at a very high risk for melanoma for a number of factors, having a family history, et cetera. And knowing that we would see a dermatologist about once every 6 months, which is pretty much the most you can hope for in terms of the frequency with which you would have an increased vigilance for looking for the changes on your skin and the moles that change. And detecting those changes early is absolutely key to effective treatments. And so, we would go into the dermatologist and we would get these checked, but then there's this idea that you want to be vigilant and that you want to catch this early, but what do you have, what do you have agency to do in those times in between? And so, what we would do is just take pictures of her moles and try and keep track of them, and they all ended up in PhotoStream, and it was hard to annotate them and know where they were on the body, and one mole looks like another, and how do you know if it's bigger or smaller, and how do you measure it? And that kind of naively led me to say, like, oh, maybe I'll just try and write an app or something. And it worked, and it ended up being the way in which I found that your phone, while it's useful for many things, the sensors that are built in via the accelerometers, gyroscopes, the microphone, and the camera can actually be a really powerful tool for you to keep track of your own health. And then in those times between when you're visiting your doctor or interfacing with your doctor, you can be tracking your own health and keeping track of the things that are important to you. And I think it's really interesting to hear, Abby, what you're talking about in terms of, like, this is a way that people want to look towards. And Ankur, when you're talking about having explicable machine learning, so that even in the best absolute case scenario where we have something that is very useful for detection or for other things, that's explicable, and that as you're using something on a day-to-day basis, that you're not just getting a blind black box score, but that you can go forward and know what you might change or might be looking out for. So yeah, I do a lot of stuff during the day, but it's a fun experience. So yeah, let's talk about it.
Yeah. So the way we were envisioning this, since we have a relatively compact group, we have some questions to start the conversation going, but we really hope you guys, if you hear something interesting or have questions to one of the speakers, not to me, about what they're doing, please raise your hand and we'll pause and we'll make sure that this is a conversation rather than a presentation. That's why we don't have any slides up. But just to get us going, so what are some of the technological advances that you're most excited about, that you think would have most visible and measurable positive impact on our treatment of cancer, diagnosing, treatment, quality of life, if you will, in the next 5 to 10 years? Yeah, go ahead.
I can start off to answer that, and I think one of the things that to me is such an absolute tragedy is that what we saw with Theranos turned out to be a fraud, because that technology, I think, still has tremendous potential to be assessing kind of not just like the zeros and ones, but actually like the wet components and the molecular biology, especially of something like cancer, where that's the main way in which we're kind of assaying some of these things. And to be able to do that in a remote setting, to be able to do that, you know, in a frequency where you don't have to remove a ton of biological material, that I still think has a tremendous potential, and it's probably going to take longer, and we need to not get so turned off by this one negative experience that we don't keep pushing for that and advocate for it.
So I was going to say Sarah is the answer to that question. As a clinician, I think one of the greatest barriers to our advancing the whole scientific field is the lack of sharing of what works and what doesn't, and the duplication of research over and over again, especially because historically, unfortunately, there has been a bias towards not publishing when a study doesn't work out the way you wanted, so nobody learns from those mistakes together. And what you're doing by creating a network of data sharing is going to advance our joint learning together really fast. And the particular example that you gave about targeted therapeutics that target, for example, a particular protein is so complicated. There are thousands and thousands of new genes and proteins being discovered, and we clinicians can't keep up, and people don't know how to test which drugs and which ones to pull off the shelf for which patients. So to have a repository where we can learn and then pool those data together to say, here's the combined experience of all of the people who have gotten this particular medicine, I think will help us really learn faster together.
But I also think that for me as a scientist, and I'm hoping this will segue into what you do, but I think, you know, having all this data in one place will really enable us to pull from the field of machine learning, because now we have a well-annotated data repository where we can use a lot of well-defined mathematical models. I was at a meeting where people were using models of, you know, based on plant evolution or game theory or you know, just general new tips and tips and tricks for machine learning, and they were applying them to cancer data and discovering which drugs could be targeted. Because, you know, there's a lot of drugs out there, and companies keep on coming up with new ones, but they don't really know if the drugs that work for maybe diabetes might work for this rare cancer, and no one really has tested it. So there's ways that we can build computational models to evaluate that. And furthermore, there's a way to change the dosing of drugs. People want to give chemo, you know, the strongest possible tolerated dose to any chemo patient, but that's actually not, in many cases, not recommended. And you want to not, you know, overwhelm the cancer so much. You kind of need to, you know, be kind to it so it doesn't actually die off and mutate into something horrible. So there's a lot of opportunity in mathematical modeling, and that's what I think is one of the more exciting things in the field.
So from my perspective, I think Amelia and everyone, the world of explanations in machine learning is really advancing at a very fast pace. And when I say explanations, I don't mean just interpretable machine learning or AI models that explain how they are doing certain things to the humans. It also includes things like, how do you ensure that a model is trustworthy, which is a huge, huge problem in medicine and healthcare. We made fairly good advances in that area at Kensai, and in general, the entire domain of artificial intelligence is really being questioned on its ability to not produce accurate results, but to produce meaningful results. And there is a huge difference between accurate results and meaningful results, because meaningful results involve human in the loop. And when you talk about complex diseases such as cancer, the involvement of that human is extremely, extremely critical. So that human-computer interaction between how a machine learning model is predicting something and how a human is interpreting those results and validating them is becoming really critical in the field today. We're doing a lot of interesting work on that field within the company. But At the same time, there is much, much more that needs to be done. So today we have auto ML. I don't know if you've heard about this term, but essentially the technology today exists to create machine learning models automatically. So you don't actually have to have a data scientist creating machine learning models anymore. You can automatically create many models. And these are very good advances because computers are really good at repeating something when you give them a recipe to do that. And we should use computers to do that more and more and more. But humans are very good at validating the output of something that the machine has produced. So the lesser burden we involve in that collaborative space where humans can do what they do best, which is collaborate and validate, and let machines do the work of analyzing and proving that the null hypothesis is not very useful, is really, really advanced in this sense. In particular, for medicine and oncology, there are huge advances in radiology, in imaging that we are all aware of. But something that you may not be aware of is completely out of left field. That's very interesting for me, which I have been doing at Kensai for the last 3 years, is looking at the cost of cancer, right? Just trying to understand in the space of healthcare, what is the effect on lives of people that when they have to pay for something, right? And we have been working with CDC for 3 years now on a very interesting project for the World Trade Center program, health program, which is 9/11 victim families and first responders. And under the Zardoga Act, Congress has mandated that it will underwrite the entire 9/11 victim family population and first responders, and we have been working closely with the CDC trying to estimate the cost of cancer and aerodigestive diseases for the next 75 years. So, we never think of cancer and cost prediction models as something useful, but it is immensely useful to understand not just the medical equation, but also the financial equation in the same way.
Yeah. Abby, you had some additional thoughts related to the cost of cancer, especially as it pertains to kids.
Yeah, it's such a funny segue because we were having this conversation in the back of the room. So to put it into context, we were talking about what's the worth of a particular medicine, and we were talking about the current immunotherapy era and the drugs that are called CAR T-cell therapies. And these have been profoundly game-changing in the cancer space, probably more impactful than decades of prior work in trying to make strides in how we improve cancer patient outcomes. And so in this era of CAR T-cell therapy, the market price for the first one to market is about $450,000 a pop, which is a lot of money. And we were talking in the back about how you decide if that money is worth it, if it's a child who's 2 and has 80 years in front of him, or if it's an 82-year-old who may not have that much time in front of him. And it's a simple equation in your mind, and we were talking about how moving and necessary it is to help these young children when you think about what we would do anything to save the life of a child in some respects. So last week in our big oncology journal, there was an article about cost effectiveness of this particular medicine. And we don't have enough follow-up data to know if CAR T-cells actually work to cure children's cancer. We haven't followed them long enough. And on average, what we do know is that about 13 months out, 40% of the children still have no leukemia, and everybody else has recurred in their disease. And so if the best case scenario is that 40% of children are put into a cure, and more realistic, it's 20% or 0 without additional treatments like bone marrow transplant, this group did these modelings of what's the cost effectiveness, and they used standard criteria that we use in health economics to define the worth of a particular economic treatment. And the bottom line was what they found is with its current costing price, which people are paying because they will, there is 0 cost effectiveness in this medicine in the long-term horizon of pediatric cancer. And if we reduced the cost by a couple $100,000 each, we would meet the thresholds for cost effectiveness, assuming best case outcome. And if we go more realistic outcomes, the cost effectiveness starts to sort of dwindle to the point that the authors said, A, we need better long-term data, and B, we need to really rethink how we consider the impact on our economy for some of these medicines. And this particular one is certainly at the forefront of our minds, but everyone in this room knows that cancer drugs are very, very expensive. They are a high proportion of the medicines that we pay for in our country. And so the research that you guys are doing is really important because it does have societal level implications for how we can maintain our overall budgets and how people will be able to pay for their health care. And Amelia, your question that followed from this conversation was, what do you do if you're a family who can't afford that $450,000? And how do we minimize the inequities that are going to be inherent in this kind of treatment regimen?
We didn't have an answer for that. But hopefully with technological advancements, the cost of some of those medicine would come down. The other big elephant in the room, in addition to cost, is the cost of data. So we talk about how much data has played a role in discovering new algorithms, new predictive models that allow us to diagnose better or to be more timely in reacting to a cancerous mole, for example. But is that at the expense of privacy? Just today, there was news that Google's DeepMind data is now going to be transferred to Google despite previous promises that there would be separation between personal data and the aggregate data that DeepMind is using. Is that a zero-sum game? Are we expected as consumers, as patients, to give up some of that privacy in the interest of the common good, or very often in your personal good, like so you get cured if should you get that disease? Or are there better ways to think about that, to collaborate with companies like Google to make sure that both the privacy of consumers is preserved while data or technological advancement is not slowed down?
I can start, but I think the answer is, there's no single answer, right? If you ask patients at large in certain communities or certain regions of the world, you will get different answers to that question, right? So in some cases, if the patients know that their data is being shared for learnings from their own conditions, and it is being shared appropriately with other physicians in order to arrive at a better diagnosis or a prognosis, I think patients are okay with doing that, right? It is the mass scale movement of data from one hand to the other that needs to go through appropriate governance, that needs to have the right policies in place. And so that's where I feel the cloud can be really a useful tool, because the amount of telemetry, auditing, the amount of governance processes and compliance that you can put in place. I mean, with GDPR standards, with HIPAA compliance laws in our country, it is really, really important to make sure that those governance protocols are always followed. For example, at Kensai, we actually have a strategy where our technology goes to the data instead of getting the data back into Kensai. So rather than taking the algorithms, so sort of taking the data in and then building the machine learning models, we've actually come up with this strategic thing very early on when we founded Kensai. The whole idea was to actually build machine learning models where the data lives under the security and governance protocols of the organization that is transacting with the company, rather than try and sweep this data all up into sort of one aggregated big data warehouse. That still doesn't sort of preclude us from learnings that we get. So the learnings and the shared summaries are still very useful. There is a lot of value in them, and you can actually really build good machine learning models through that strategy and share. And in fact, when you talk about sharing machine learning models that were built for diabetes or oncology in one region of the world with another region of the world, and trying to create a holistic model that works for everyone, it's actually very useful and liberating to see how good your accuracy and prediction models can get across by sharing that. The other thing that we have done well is we have actually published everything. So we believe in an open publishing model, and we often collaborate with our researchers and partners within these health systems, where we'll immediately put out the results and we'll talk about it, and we'll sort of share the parameters that we used, so that the data access that we have is actually being used for public good, if that's the part of the contracting process, right? And I mean, I cannot thank initiatives like Sage Networks enough, because data is only useful when many people are looking at it collaboratively from different perspectives. And so, the efforts that are in the collaborative space of analyzing large data sets are super important. Also, the de-identification and anonymization technology today has improved significantly, where we work a lot on de-identified data. So we actually scrub out any PII, PHI from those data sets before we do the machine learning part of it. So that also helps us in sort of mitigating some of those data leaks and problems that may come with governance of that data. So we've taken a very strategic as well as patient privacy first, analytics later type of an approach. Even at the cost of making maybe compromises on precision at some point. We want to make sure that privacy is forefront of our governance strategy, and the health systems that we work with are actually quite comfortable with that. It's like giving a physician 7 factors on which they are making their decision today, and with a sort of 20% or 10% precision. And if a machine learning model can give you 40% precision compared to that 20% precision, even with de-identified data, that's actually a huge lift in the care protocol itself, which would have taken a huge amount of time for a physician group to come together and realize. So we are really fighting death versus data science at this point, and any improvement in that incrementally, even at the cost of loss of accuracy, but preserving the privacy, is extremely, extremely valuable today.
I think your approach is a little bit different than Google's, though, which is if you're taking to the physician the information about your health, as well as how much you drank last night, or whether or not you hung out with friends, or whatever other unhealthy habits, it's the correlation between health-related data that is not anonymized and personal data that comes outside of the health contract that you have with Google. I think that's the biggest concern.
I cannot comment on Google's strategy.
Yeah.
But I think it does bring to light this natural tension that I think is healthy for health science, that people, we have to keep track of what's ethical and what's right for the world in terms of sharing data and what we should share and when we should anonymize and so forth, versus what will bring a cure faster. And I think at Sage, we have a governance team that struggles with these issues, on a day-to-day basis, and they really work on making things ethical at a cost to sometimes the science, where I spend a lot of time on the phone trying to convince scientists that we have a very secure platform that they can upload, and then we can, bring their models to the data if they need to. But it will not, impact their own HIPAA compliance or GDPR regulations or whatnot. So I think there's this natural tension that really makes us really discuss every time we get a new data set in, who is this impacting? What is the size of the patient population? For example, if you start going to very less populous countries, you can really identify people with very little information. So there's a lot of factors that come into play. And I think, it's good to have trust, but it's also good to be a little suspicious, because you really want to know where things are going, and if they're going to be going to your insurance company or Google for advertising. It's important to know.
Thanks for saying that, Sarah. I wanted to add the other tension that I think we are going to see in this intersection of health and tech is things that are identifiable, we don't know yet. So there's a lot of, for example, genetic information that we think should be unidentifiable and therefore outside of the realm of HIPAA, which for those who don't know is the standard ways that we protect patient privacy things. But very soon, particular genetic pieces of information will be able to be associated to individual patients. And so we're on this learning curve as we go about how do you navigate what needs to be protected under privacy guidelines. Do we change those guidelines? How do we inform the public that, you know what, a lot of stuff is actually going to be disclosable in some ways within the systems. And that's actually true in health systems in general. You walk in the hospital and they do a blood test. Your blood lives in the lab and we can use it any time. And most patients don't actually know that, but that's this sort of secret pact that you make with the hospital when you walk in the door. And so I think a lot of it is just real transparency with how we do this work over time so that the public is aware. Because the thing with Google, I think, that really upset people the most was just they didn't know. And that surprise felt insulting.
Yeah, exactly. I want to pause and see if there are any questions right now. We can keep going. We have a lot of other topics to cover, but I wanted to give you guys an opportunity to raise your hand. Well, let's move on. One of the aspects that we touched upon is there was a recent article in the New Yorker that summarized some physicians' negative reaction to technology in the examining room. Negative reaction in terms of they all appreciate the accuracy of new tools, but some technologies are crowding out that important patient-physician relationship. And I wanted to ask Abby in particular, because A, you're a physician, but you're also building an app that is, as parents will lament how much time our kids spend on phones, yet we keep producing things that are designed to help them and that are designed to scale the help. How do you balance that? And have you, from the results that you have seen from PRISM, have you seen your concerns either validated or are the benefits worth the cost?
Okay. So first, the development of PRISM was done with what we call user-centered design. So we started with teenagers because they were our stakeholders who could communicate more easily than younger kids. And we said, what should this look like? What's been important to you? What skills have you learned? And then we translated that into something that we then iteratively tested with patients and families until we got it right. And part of the design was, with the app in particular, was, as you guys heard, teens and families told us, this is how we want to learn these skills. And more importantly, they said, in particular for the teens, I want to do this at 2 o'clock in the morning, and you're not going to come hang out with me at 2 o'clock in the morning. And so what we did was we listened to them and said, how can we do this? And in so doing, we partnered with parents who said, my kid needs help, and I want something that will help them. And so in that respect, I don't think that at least our program is interfering with the patient-doctor relationships. I think it strengthens them. That said, I'm not doing this with a kid when I'm in the room with a patient. I feel like there's a lot of research in medicine, so I'll just tell you my personal experiences. I feel like when I have to take notes at the same time as having a patient interaction, that disrupts the beauty of that conversation. And so I don't do it. And it takes me 4 times as long to then do all of the other charting and the notes that I have to do outside of the room. And I'm saying this because I think the field needs to understand that there is an additional tension with what our job requirements are to use technology to speed up our processes. And yes, we sacrifice the thing that we all got into medicine for in the first place, which was being next to another human being and being a part of their lives in a really important moment. So I think it's a problem. I really do. I think we're going to have to learn together.
Yeah, I'd love to hear from the mole mapper.
Well, yeah, and I think that, far from, it can actually be much more detrimental depending on what it is, because you only have so much time with your patient. And then in speaking with cardiologists, for example, when a patient comes in with their continuous heart rate data from every second from the last 6 months, and you have to spend the first 9 minutes of maybe only 15 minutes that you have saying, I know that's a speak. There's really not much I can tell from that, and it's more explaining things that aren't helpful, designing these things so that just like you're speaking with patients about what they need, speaking with doctors about the language and the currency that they're using in those interactions as well, so that when you're coming in, just to use the example of MoleMapper, when you come in with those pictures and you get to see with your doctor, they can swipe through and see the currency that they're used to, which is looking at someone's skin. And they can do that and say, here, it's like having 6 visits in one kind of. And being able to do that makes it more efficient and collaborative as opposed to, what is this exactly?
Yeah, I mean, I'll play devil's advocate and go against what I just said 5 minutes ago. And so, two things. One is, if the patient has that continuous heart rate monitoring, because everybody does now, or their sleep actigram or whatever else, and that's really worrying them, then my job is still to go there with them. So maybe that helps because it is something that's on that patient's mind. So as a system, we need to figure out how to meet patients' needs. And then I'll share the counterexample. There are some apps that manage symptoms for patients and help patients track symptoms in real time. And then that data can come to the physician so we can see, for example, that a patient was really bothered by dry mouth. And I can tell you, I never ask my patients if their mouth is dry. And when I'm doing my kind of history, I talk to them about, did they have any nausea and do they have any rashes? And I ask them all these kind of typical questions. But these apps enable patients to identify the things that bother them the most. And then I get the data in advance. And so I can walk into the room and instead of asking 50 questions, including missing the one that's really important, I can go directly to the thing that's bugging them. And I can say, hey, it looks like you're having some real difficulty with dry mouth. Can we talk about that? And so I think, as we've been talking about this whole time, there is a tension as we learn together, and there's a real opportunity, and we need to be aware of the potential detriments.
So pretty much as with anything, smart usage is better than just blind usage. So you are all researchers, scientists, physicians, but have made in one form or another the transition to entrepreneurs. How is being an entrepreneur different than what you studied to be? Which one is more rewarding? What lessons you're applying from entrepreneurship to your day job or the other way around? I'd love to hear from you. Go ahead, Ankur.
So I don't think it's anything different than what I was doing as a professor or continue to do as a professor. Innovation is something that has been in my sort of blood for quite some time, and I've been very excitable about creating new things. And now I do that as part of Kensai more than what I do as part of UW. What is fundamentally different though is the impact that I can have as a researcher versus closing the loop of that impact as an entrepreneur. So what has been really eye-opening for me as a personal journey is being able to start something that was homebrewed in a lab and looking at some data, building a few predictive models, and then somebody coming back and asking me, hey, can you deploy these models in production to actually save lives and make something better, right? And that's where sort of the big aha moment happened. And like, yeah, we can create a machine learning platform for healthcare that serves up machine learning models faster than what it would be with traditional data science approaches that can crunch that data and produce features at a much better rate than an experimentation in a lab could do. And that, if that is of immense and huge value in order to accelerate the delivery of AI and ML in the actual healthcare system, then that's hugely valuable. So I always wanted to see my work applied, and Kensai became a great vehicle and mechanism to actually go and work with physicians across the world to see that vision come full 360 degree and reach a great conclusion. So I continue to be very excited about the challenges that I face on a daily basis, and entrepreneurship is just one more sort of chapter in that story. I don't think it's like a new book or anything like that.
Anything to add, Abby or Dan?
Best job in the world. So I went into medicine because I wanted to take care of kids with cancer, and I do, but in a very different way than I thought I would. And I think what is the most exciting to me, I don't know that I would call myself an entrepreneur, although thank you. I will want to be an entrepreneur. What is the most exciting to me is this huge horizon of how innovation can improve health. And to be part of that with this team of amazing people up here is awesome. So that to me is the most exciting. There are days when I wake up and I think, I can't believe that people pay me to do this. And it is a tremendous privilege to be able to think creatively about how we can improve cancer outcomes for patients and families.
So I'm not an entrepreneur at all, but you kind of gave me the lead-in to sort of describe, I think, where the real gaps are. I did a very thorough job search after leaving my postdoc at MIT, and I really wanted to explore academia and industry, and I just looked at everything just to see what was out. There's a large startup community in Cambridge where I was living, and I really just interviewed and talked to a lot of people, and what became very apparent was that there's this huge gap in cancer research, right? You have these scientists in their labs trying to build their academic empire, no offense to academics, so they can get tenure and get funding. And then you have the drug companies that are reading the papers that are coming out of academia, and they focus on a certain target, and they just they build their whole pipeline about it. And no one's kind of trying to bridge the gap between the scientists in the lab and the drug companies. And there's so much acceleration that can happen if we just learn to think a little bit differently and try new technologies and getting people to communicate or think a little bit outside the box or use that app or develop a tool. I think there's a lot of space that can be filled by entrepreneurs and people that are willing to think differently.
I want to give you one more. Yeah, please.
Let me get the Mr. Microphone going.
Thank you. This question is directed to Abby and to Sarah. I appreciate your approach to patient consulting, put away the electronics and listen to the patient. But to Sarah, isn't there some process where she doesn't have to spend 4 times the amount of time outside the interview to record all that data? Then it can be shared cross platforms. And so I've heard, everybody's going digital and all this, but it would seem to me that there'd be solutions already in place other than having a scribe sitting alongside her recording.
I don't have an answer. First of all, thank you for asking a question and getting the audience questions started. We really appreciate that. Do you have an answer, Sarah? I think this is a really important question and something we need to work on as a field. And I'm optimistic that we're going to figure it out with a very steep learning curve as we fix the electronic medical records and how we do that interface. I think technology is potentially the way that we'll be able to do that. We haven't figured it out yet, though, and I think we need help.
I think actually I can answer that with some of my tangential design background. The way electronic health records came about, actually, their goal was not necessarily to improve the patient-doctor relationship. The goal was to facilitate easier billing. So that's why the software is so complicated and so cumbersome and so counterintuitive to the patient-doctor interaction. And they haven't figured it out because it's a complex, they are working and there are startups actually trying to disrupt the EHR software space. But the systems are so cumbersome and it takes such a long time for a hospital to adopt a solution like that it takes a while. I think what gives me hope is that we have actually doctors and researchers and people that are in the field now developing the solutions that, through technology, that would help them have better patient relationships or better scientific collaboration relationships rather than having an outsider design something that's optimized for revenue rather than revenue plus experience.
Yeah. I'm really glad you brought that up because I think it really comes down to what we talk about a lot at Sage is incentives, right? The insurance companies have a lot of money and they have an incentive to get these systems in place, but they come from a user-centered design approach. They're not really focused on making that the data transferable or open. So you can have the same company build EHR record systems for 2 different hospitals across the street, but they could be totally uninteroperable. Because they're built for different hospitals and they require a lot of extra money to pull the data out, to compare. I mean, they're just not really built for anything other than the billing. So I think it comes down to the incentives, like how do we get money into this system to make it more open and shareable across communities and really better experience for the patient.
I just wanted to say that everyone should read the Gawande article in the New Yorker because it does a lot more than blame the EMRs
Oh,
for
definitely.
billing,
no.
you know.
Yeah.
I mean, I think what it really says is that the system is managing the doctor instead of the doctor managing the doctor-patient relationship. And I just wanted to bring up the idea that a lot of healthcare is scheduling. And so a lot of what you guys are talking about is figuring out the diagnosis. And the diagnosis can almost be done abstractly or with a automatic interface and all that stuff. And you see how Big Blue can find much better diagnoses and so on. But from a patient side, my wife wants to get a test. First of all, she can't get on the phone. She's just waiting for somebody to answer the phone for an hour, okay? And then she can't schedule the test because the machines aren't available for 3 weeks. And then once she gets the test and it's some serious problem, how long is it going to take to hook up with the proper provider? So when you were talking about stress in managing cancer patients, a lot of stress probably comes from the patient not understanding what's going on, the patient not being able to understand what the doctor is saying, or get a test, or do the follow-up that's necessary. And so I think that there's plenty of opportunity for technology to improve scheduling.
Oh, definitely.
Scheduling is a hard problem.
And the more complex the condition is, the more complex the scheduling is as well. There is actually a company that couldn't join us, but they're based in Seattle. They're called Navigating Cancer, and their entire value proposition is create a platform for all the different practitioners you would have to work with on your cancer journey, and you as a patient and your caregivers and anybody that's maybe giving you rides or helping you with chemo, just coordinate better. But even then, even with this platform, for you to take advantage of that platform, all your healthcare providers need to be also members of that. So it's definitely a complicated area, and the more complex the condition is, the more complicated the solutions are.
Yes, let me add 2 cents to that. So at Kensai, we have machine learning models and solutions for care, cost, and guess what the third area is? Ops, right? So we do a lot of operational optimization for health systems, and we work on a solution called Patient Flow that essentially is supply chain optimization problem for healthcare, where we predict the number of patients who are going to show up at the ED, and from that point onwards, how many ambulances are going to show up at the ED in the next 1 hour, 4 hours. We integrate that with weather information, with sporting information that's happening in the city at that time. And then you essentially predict how many of the ED patients are going to transition to become inpatients into the general ward. What is the load that it's going to put on radiology, on labs. And then you have this whole suite of predictive models that flow in order to give you a general sense of how that hospital's patient flow system is moving and what is the throughput of that system. And that helps us immensely in, sort of cost efficiencies of making the staffing decisions better and optimizing for that so that the patients get minimized wait times in the ED. And I encourage you to look up some models. So it's also a little bit of policy that plays a huge role in interoperability. Sweden, in fact, is doing something very amazing that we can learn from. The Karolinska health system in Sweden has done away, or is in the process of doing away, with departments. So there are no longer going to be departments. There is no department of cardiology, or there will not be a department of cardiology. What they are doing is they are actually taking a very innovative approach of having a patient navigator assigned to every individual patient in the system. So as soon as that particular patient shows up in the A&E or ED, that particular patient navigator will be responsible for care coordination through the entire system as that patient goes through it. So fascinating things are happening, and people are trying to solve the problem using either people, process, or technology. So it has to be one of the three, and I think we have to attack that problem from all three pivots to make it successful.
Thank you. I'm going to pile onto the gentleman's statement about the scheduling. Another issue is, I think, I kind of came here, I thought we'd be talking about AI and machine learning on the high-end, therapeutic stuff. We're talking now about bread and butter stuff. So I thought I'd add something. I work for the U.S. Department of Health and Human Services, and Secretary Alex Azar, I know we've talked about this at Kensai. The FDA makes a drug maker communicate in its advertising the side effects, but not on your wallet. And I believe in oncology, they use the term financial toxicity. I think I've seen that in the journals. And as we're talking about scheduling among different clinicians and all that, even for normal stuff, people who are not sick, just like a middle-aged man like me, I can't figure out what I'm supposed to pay out of pocket. For a cancer patient, I can't imagine how you manage that. So as a clinician, how do you face that challenge?
We know nothing. We're really poorly informed. And it's a really important question. I think different payer models, different hospital systems. So if a child is at Children's versus Swedish, they're going to pay different things out of pocket based on the hospital system level things. And we need to do better with that transparency. The other thing that you guys are talking about when you're talking about financial toxicity is the larger unmeasured costs. How much time did you have to spend on the phone scheduling that visit? How much time did you have to take off from work to go do all of that stuff? What is the impact of job loss of the caregiver who has to be at the bedside when you get sick? There are so many implications that we are just beginning to understand, and you're right, we need to systematically be able to counsel patients and families better about what this will be on your wallet and on your life.
Go ahead.
Yeah, hi. My question is for Sarah. So maybe I just had a very naive view of the healthcare industry, but I was under the impression that lots of companies didn't want to share their data. You look at, for example, companies trying to patent certain parts of the genome and saying only we can work on this portion of the human genome, or Theranos was famously, the reason they got as far as they did was because anytime people asked questions about their technology, they would invoke trade secrets, or drug companies patenting and monopolizing on one areas of drugs so no one else can sort of test them or work on them. So has it sort of evolved, and is the mentality more to share data now, or is it changing, or maybe I just wasn't aware that companies wanted to share data?
No one really wants to share data except for the patients, right? The patients are very, very strong advocates to sharing data. And I think, and we've kind of been strategic about that because you're right, drug companies, and this is my experience when interviewing, they have their patents and they want to apply those patents and tweak them just a little bit so they can continue the patent ownership, right? And the academics, they want to publish first, so they want to keep their data in their lab until absolutely necessary. And we actually have this very difficult relationship with the National Cancer Institute because they fund us to, share the data from their funded grants, but their grantees don't want to share it. So they don't, it becomes a very complicated back and forth. But I think what we've done is, be strategic about it. So we get communities involved, like the neurofibromatosis community is very small. I work with foundations. Often these foundations are, initiated by parents of kids with this disease. So they just are basically like, well, you don't get your check if you don't share your data, and we're not going to fund your research. And the scientists need their research funded. So, and we have other program directors. The NCI is not so great, but another National Institute of Aging has a data sharing grant that they really do enforce funding. And that's where it comes down to. If you don't share your data with the taxpayers who are funding you, you will not get your money. And the same goes with open publications as well. There's a larger push in the scientific world that, this is actually benefit. You are funding a lot of cancer research with your tax dollars, and you can write to your Congress people and senators to really make sure that, this is getting open, because we are trying to change that. But
Or go to Sci-Hub.
yeah. So to try to get that. So hasn't changed, but we're working on it.
If I may follow up on that, aren't you concerned that you're eliminating drugs from ever getting to the patients? Because if all the researchers are publishing their data, they're going to lose their IP. And then there's zero incentive for a for-profit company to come in and spend tens of millions of dollars to go ahead and develop it.
I mean, I don't do any drug development, so my goal is to get the academic work out there faster. I think there's a lot of public-private partnerships out there, and the people that are building data resources, there's data resources coming out of the EBI in Cambridge where they're building these resources, but they also have private databases. I was at a cancer systems biology meeting in San Diego where you had these people from companies that had their own data resources that integrated with the public resources, but they didn't share them. So I think our goal at Sage is really to build the infrastructure that people can use to maintain these systems, and even if it accelerates the private drug industry, it will help the community. So I don't think we're trying to step on anyone's toes, but we're rather trying to, again, build the infrastructure to make these companies more efficient.
I would just add to that to say that also as kind of drug development moves more away from medicinal chemistry, and you have a target, you have a molecule that can be synthesized by a known pathway, et cetera, and more towards biologic therapies where you can have the same target where you have different essential pathways to creating that molecule or different variants therein. And so it's not so much like winner take all for some of these things. And so I think that's becoming hopefully less of a concern, especially as you're finding that you're getting different targets throughout a pathway and different ways to hit those, that it's really, it's rising tides for everyone. And so I think that thinking is going away a little bit more.
Fantastic. So is there a mechanism for me as a patient to anonymize and share my data to help for the greater good, as it were? 39-year-old, married, 2 kids, here's my whatever.
So this is where I get to put in a plug for the NIH Precision Medicine Initiative's All of Us research program. And so this is a nationwide initiative to do exactly what you said. And it is a longitudinal study where you can enroll in this program and share everything from your electronic health records, your biosamples, and then digital health technology that you're using as well, and all of that coming together to create this shared resource. And so as a person like you can enroll with a health provider organization. You could do what I did. I went to Quest Diagnostics that's in a Safeway and do that enrollment. And so we're really trying to get to people like you and to people throughout the U.S. that's representative of our entire population.
And there are digital platforms like Patients Like Me that are condition specific.
The problem with the problem with data is that the data has to be, good data, right? And good data is data that is diverse data, right? So, 80% of people like you sharing your data is not very useful. No, I don't mean to be offensive. I'm saying, for good analytics and machine learning models to work well, right? That are trustworthy, that are explainable, that are fair, and work in all sorts of conditions across age, race, gender, ethnicity, backgrounds, income levels, demographics, genetic conditions, comorbidities, right? It is the heterogeneity of that data that really makes the algorithm shine, right? Because it's not enough to build a predictive model for predicting someone to be, at stage 4 cancer in the next 6 months. It's extremely important that that model is robust across populations and is widely applicable to any type of a child that comes into that ecosystem in order for that model to be useful for someone who's practicing medicine and making sure that they are helping the patient outcome, right? So it's great, by the way, it's great that you are stepping up to that, and there are many like you who are stepping up. But we also need to be very aware that that it's not only important that we get a lot of data, but we get good quality, diverse data. So it's really important that we have an ecosystem that allows for that.
Let me add one last thing to that, which is in addition to like having lots of data and having good data, the fact that that data is widely collected is where you get sometimes not just representative of an overall model that fits everyone, but you get these very rare individuals that can lead to breakthroughs. And just very briefly, the story of HIV infectivity, where being able to broadly assay a population and find that there's this very rare subset of people that despite all of the risk factors, despite even sometimes getting blood transfusions from people that were HIV positive, these people just would not show any signs of the disease. And it turns out you go back, you find out they have this one little mutation in a gene called CCR5, and that happens to be the receptor that is used on the immune cells to become infected. And so you find these rare individuals, and then because we were able to broadly assay and find that, that now translates and is being used in gene therapy as we speak. And so being able to have people like Ben, who admittedly, so boring. No, we don't want more of you. But, and we're being facetious, right? But that you might be that rare individual that has that we can then extrapolate to everyone else. Yeah, but sorry, you had the question.
This is loud. Okay, can you guys talk a bit about who pays for the products in health tech, and how you go about convincing people to adopt the products that you're building?
So we're learning. Who pays for the research and who pays for the clinical development is often different and so the question you're asking is who's the customer? And I can speak to our program, that's what we're trying to figure out right now. And so the models that we are playing around with and we're talking with all of the potential stakeholders is, do I sell directly to you as the consumer and my potential patient, and I put this thing on the App Store and say everybody should have it? People are shaking their heads behind you, you can't see them. Do I sell it to the insurers because I know it's going to be a cost savings thing to them in the long run because it's going to minimize the risk of depression and all the other medicines that these kids are going to have to take? But then do the customers trust the thing that their insurance company is pushing? Do I sell it to hospital systems and say, we think this is a really important investment in your overall medical models, and then who within the hospital gets to make that decision and how is it delivered and implemented and deployed? And then it becomes extra complicated because how Seattle Children's does it is different from how Swedish does it, is different from how Boston Children's does it. And so we are learning right now in this new horizon about how to systematically implement and disseminate tech that is helpful to people's overall health and well-being. And I think other than the electronic medical record, we don't really have a good system that works for every patient and every health system in general, at least in my experience.
In our case, Kensai works with very large health systems, with accountable care organizations who are transitioning to value-based care, with government organizations across the world who want to have better outcomes for their populations. So each of these individual sort of organizations pay for the solution. And the solution that they get is not just sort of AI, but we like to talk about it in terms of BI, AI, ROI. Right, and the ROI is really important because with every solution we have the burden of proof to actually produce the return on investment on that dollars that they have invested in the Kensai solution. So we are very upfront about that. ROI impact, and as a private company, to remain solvent and keep growing, we actually have to prove that ROI every day in and out. So our solutions are actually targeted towards that ROI realization as quickly as possible, right? So we work with chief financial officers, we work with chief medical officers, with CIOs of the organization in order to make sure that their budgets that they're allocating to the technology that we are providing them is actually returning a 3x, 10x, 20x return on investment to them.
Oh, wow. So my name's Tammy. Hi, I'm with Cancer Research and Biostatistics. And the issue about diversity, I think, is really important. And I would like some comments on bias built into the algorithms that's driven by the programmers who we know this happens. And how are we going to address that and correct for it?
No, great question. As a researcher and a data scientist working in this field, Tammy, for the last 20 years, I cannot applaud you more for raising that point, because this is central to success of algorithms today, right? And I can only throw some light on the advances that the entire AI community that I represent in some sense today is making to make sure that our algorithms and our machine learning models are fair and transparent. To give you an example on the type of things that we are doing specifically in Kensai, for example, are before we put a model, sort of the result of a machine learning model for risk stratifying a heart failure patient or risk stratifying an operational efficiency, when a patient shows up, is we measure the predictive power of that algorithm across various cohorts that are available in the training data set and try to build some sort of a safety valve or some sort of a safeguard in trying to understand how generalizable will that model be across different subsets of that population, right? And there are many theoretical sort of loss functions, risk models that one needs to create in order to understand better the performance of that model across various diverse populations. I don't think we are anywhere close to a perfect solution yet. I don't think anybody is. But there is a very big movement going on in the AI community, and I highly encourage you to read up on that. There is a big conference happening next month in Montreal called Neural Information Processing, NIPS. It's one of the largest conferences in the world of AI. There is another conference happening closer to home in Anchorage, Alaska in summer called ACM SIG KDD. Plug for myself and Amelia here. I'm the general chair of that conference, so you are more than welcome to attend that. And there is a lot of conversation that's going to happen in these forums where 3,000, 5,000 AI scientists actually get together for 4 or 5 days, simply focusing on all aspects of AI. But fairness in AI is really critical, and we are doing everything we can, but we need public awareness about these things. And of course, for my academic colleagues, put in a plug that we need funding for this as well.
So the other thing to keep in mind is that in cancer, there's still not a lot of data. There feels like there's a lot of data because we have thousands of patient samples, but they are going to be, and there is obviously inherent bias in the data, but we're not talking about LinkedIn hiring stats for which you have millions of people and lots of variables. We just don't have, you have, maybe even within breast cancer, there's many different types of breast cancer, and once you start whittling down all of the basic factors that pathologist measures, you don't really have a lot of samples to deal with, especially when you're trying to find patterns among 16,000 transcripts and 20,000 genes. It just becomes a very high dimensional problem very fast. So I think While we're, at least at the population level, the epidemiological level, we're worried about bias, I think there's still a need to collect quality data, like really good data, and make sure that's robust and open and curated, which is just less fun than controlling for bias.
Yeah, I think one thing I forgot to mention is, healthcare is at least fortunate that we have a lot of regulation and control before we are able to, produce something that is used on a patient or, used operationally in a healthcare setting. I want to make you aware of certain other domains that are slightly less regulated, but actually have a bigger problem. Financial lending, for example, there is huge papers coming out now that talk about biased loan adjudication systems that are, not up to the mark, judicial systems where, parole decisions are being made on black box machine learning models where certain ethnicity and races and genders are being discriminated against blatantly because the companies that hold those models are under strict governmental contracts to act by policy to actually not share what are the factors on which the model is making that decision. Should the defendants game those models? It's just insane. So, before we cross that bridge in healthcare, I think there is much work that needs to be done in slightly lesser regulated markets that need to be, better understood. And AI really needs to make a lot of strides in those domains first before we even sort of, have an inkling of some progress in healthcare. Though we are trying in healthcare as well.
Dan, yeah, go ahead and.
I'll be really quick. I think that the answer to your question is straightforward but really difficult, and it's weather vanes. And hang with me, because the idea is that when we predict something like the weather, what we have throughout the world and throughout the US is we have weather vanes to tell us when we're wrong. And we cross-check everything that we do, and there's a feedback function every single time we do it. And so when these systematic biases are built in, but then there's no feedback and there's no weather vanes out there to report back, that's when those persist over time.
Well, thank you so much to the panelists for the great discussion and to the audience for sticking with us, and join us again for the next event.